Today we are going to create this awesome procedural hologram effect using geometry nodes and shaders. To get started, I am going to import a character model with an animation that I downloaded from Mixamo. Then I add an empty circle, rename it to master controller. Add another empty, make both of them visible in front in the viewport. Rename the second one to holo source. This will be our hologram projection source. Then I add a mesh plane for our hologram, call it holo. Now I parent all of these objects to the master controller. Now I'll put our character model and its armature to a different collection. Select both of them, hit M, new collection, and put it to a new collection. Although this has put these two objects to a new collection, it will keep the armature parented to the master controller. Hide that collection. We don't need it to render. Now we have set everything up. Let's go to Geometry Nodes workspace and make the hologram. First, I rearrange the layout to fit the project. Select our holo object, create a new GeoNode setup, remove the input and output connection. To create the hologram, I drag and drop our character mesh and set it to relative. Now I also drag the projection source object to the setup as well. First, I am going to delete a part of the mesh that is from a certain distance from the source. I have done this before in my previous videos, so let's quickly measure the distance between each point of the mesh and the source object using the input position node and calculate the distance with a vector math node. Now, to mask out a certain distance, search for less than node. To delete the geometry, use the delete geometry node and plug our mask to the selection socket. This B value will decide that certain distance from the source object. Now to the next step, projection beam. To create the beams, I start with a curved line. Set the type to direction. Now I take this curve and distribute it across the surface of our hologram. For that, first we need to create points on the surface. You can use either distribute points on faces node or mesh to points node for that. But here I stick with distribute point on faces node. Since we have to deal with big numbers for the density, I use a multiply node to make it easy to control. Our points are a little too big, so I use set point radius node to scale them down. This is only for visibility. This won't change anything in our geometry. Now let's instance these lines to the points using the instances on points node. To combine this with our hologram object, I use a join geometry node. So we got our object, we got our beams. Now we need to make them look like they are coming from a projection source. Basically, what I want to do is I want these beams to look at the source object. If you have ever used the track to constraint in Blender constraints, that is exactly what I am going to do inside geometry nodes. In order to replicate that, I need to individually control the rotation of each instance. For that, we can use the align Euler to vector node. Plug it to rotation and set the axis to Z. Now I connect this vector input with the projection source location and subtract the position of each point. This will make all of these beams or lines rotate towards the source object, wherever it is. But it didn't get the scale right, the length of each beam. To change the length, we can use the Z value. Since we have the node set up for calculating the distance already, let's use it to change the scale. Combine XYZ node and set the X and Y to 1 and drag the distance to the Z input. Now look at that. We got our beams projecting from the source to the surface of the object. I mean, it looks like that, although we did the reverse. But these beams right now are just curved line. They are not going to render. So to turn these to mesh, use curve to mesh node and use a curved circle with a low resolution for the profile curve. You probably have to reduce the radius a lot. Let's use a multiply node to make it easy to control. In that way, we got our basic hologram. Let's extract some of these values. And also, I'm going to create materials for beams and the object. So let's add a set material node to both of them and create and assign them to each other. Well, we got a little bit more stuff to do with geometry nodes, but let's head over to the shading workspace and create the hologram material. First, the beam material. Delete the principal node and add an emission node with a transparent node and mix them together. Since we are dealing with transparency in Eevee, let's change this to alpha blend. Turn off show back face. Now I want to create a gradient for this alpha. Here in GeoNode, since we are dealing with curves, we can use the spline parameter factor to get a 0 to 1 range gradient. So after instancing the curve lines, I add a capture attribute node and capture the spline parameter factor. Drag this to group output. Let's call it spline factor. Now if I give the output attribute a name and use it in the shader editor through an attribute node, we should see a gradient. Well, we got nothing, and that's because we haven't realized the instances yet. So let's add a realize instances node. Go back to the shader editor and immediately you can see it's working. The spline factor attribute created a 0 to 1 range or a black to white gradient from start to end of each curve line. Let's use this as mix factor and switch these two shaders because I want the black areas to be transparent. Here I used a color ramp to increase the contrast. Give the emission a color and more strength, and here we have our beam. Here in the final effect, I also add these 2D looking lines that slowly go upwards. To make that effect, use a wave texture with window texture coordinates and set the direction to Y. What window coordinates does is, it maps the texture based on the size of the window you are looking at and also the distance you are looking from. So to get the correct size, I add a camera and adjust the scale from the camera view. Now let's use this with our gradient. Here using this phase offset, we can make it look like it is going upwards. Like I said earlier, the distance you are looking from also matters to the scale. When we are using the camera, there will be times that we want to zoom in or zoom out. So we need to make sure this scale will change according to it. Since we have a method to calculate the distance in GeoNodes, we can use that to update this value. To fix our scale in the GeoNode, add the camera to the setup and calculate the distance with the projection source and output that as an attribute. Now let's give it a name and use it in the shader editor. Use that with a multiply node for the scale. Now since the scale value depends on the distance from the camera, when we zoom in or zoom out, it will adjust the scale of the line to make it look like it is not changing. I will use a color ramp to further adjust the wave texture. Now, since I'm going to use the same setup for the hologram object material, I group these nodes and extract necessary values, such as scale and phase offset. Let's do the same for our holo object material. To create that outline edges look, I use a layer weight node and use it facing output. Adjust the blending to your liking. What this does is, it's create a black-white gradient depending on your viewing angle. If you are looking at this object with a certain angle, the surface areas that are aligned with your angle will be a value of 0, of black, and the surface areas that are perpendicular to your viewing angle will be a value of 1 of white. Increase the contrast a bit and use it as the factor. I also wanted to add little dot all over the object. For that, use a noise texture with object coordinates. Increase the scale and use color ramp to increase the contrast. Now add this to our gradient and check clamp so we don't go over the maximum value of 1. Now let's add the group we created earlier. Shift A, under group, find our group and multiply it with our gradient. To smooth out this harsh edge at the bottom, I use the object coordinates of our hologram source and use its Z value to make a gradient. Use a noise texture to add some noise to it. Multiply this with our gradient as well. Here in Eevee, you will get this harsh edge when you are dealing with multiple transparent objects. You can get rid of that by enabling the show back face option, but it will introduce some other issues. You might be able to get rid of some of those issues with making back faces transparent and deleting some unnecessary parts of the mesh. It won't be perfect, but I guess in some cases it will blend with the whole holographic thing and probably won't look that bad. So let's animate this. But before that, it will be awesome if you hit that subscribe button. To animate the offset, I started with a higher value like 100 and created a keyframe. Go to the end of the animation and set it to 0. Here I roughly check the animation and change the beginning value to 50. Since I want this value to link with the value in the other material, I am going to create a driver for it and link it with this material. For that, right click on this value and copy its data path. Go to Holo OBJ material and on the face offset, right click, add driver. Here, set this to single property. Set the ID type to material and pick the beam material. Now Ctrl V and paste the path here. This will link the previous value and give it a name of 𝒂. Here in the expression field, we say we need this face offset value to be 𝒂. By the way, you can change this to any name you like. Just make sure to match these two fields. Hit update dependencies every time you make a change. In that way, we have successfully linked those two values together. Do the same for the scale as well. Now, I am going to animate the strength of our emission. Create a keyframe and in the graph editor, select the value and add a built-in function modifier. Choose sine function. Now, play with these modifier settings to give this a flickering type animation. Do the same thing for our other material as well. For the hologram object, I used slightly higher strength but kept the flickering rate the same. I wanted flickering animation for the little dots as well, so I changed the noise texture type to 4D and add a keyframe for W value. Then add a generator modifier in the graph editor. Change this value to reduce the speed of the flickering. Now let's create that rotation animation. In the geonode, I drag this factor to group output, then disconnect it. The purpose behind that was to get this nice slider in the modifiers tab. So we have this slider that goes from 0 to 1. When it goes from 0 to 1, I need my hologram to scale up and rotate to the current place. First, let's call this animation. To rotate and scale the hologram object, we need geometry transform node. Here, I'll change this Z value with the animation slider. Add a combine XYZ node, add a math node. Plug the animation slider to its one socket, and for the other, I type pi, which is equal to 180 degrees, and drag the output to Z input. Change the math type to multiply. Now, when you go from 0 to 1, it will rotate the object 180 degrees. Since we want it to face forward at the value of 1, I add another math node and change its math type to subtract and plug it like this. What this does is it gives our hologram 180-degree turn at the start, and when the slider goes from 0 to 1, it will subtract 180 degrees from it, resulting it to face forward. Let's drag the scale to the animation input. Since we want the scale to go from 0 to 1, it can directly use the animation value for all three axes. But in order to make it work properly, we have to change our deleting mask value. So I multiply our visible threshold with the animation value and plug it to our B value. Let's do the same for the density of the beam. And just like that, we have an awesome hologram animation. You can extract the rotation value to have an easy control over it. If you like to change the hologram emission color directly from the geometry node modifier, create a color input, give it a proper name, color, and directly plug it to the group output. Give it an attribute name and use it in the shader editor. Do it for the other material, and in this way, you can also change the hologram color directly from the GeoNode modifier.
Told you, that big red button. Subscribe to HellFX. Hurry up.
So, what do you think about today's video? Comment down below. And also, if you make something using these techniques, don't forget to tag HellFX. I love to see those. So, as usual, all the tutorial files and demo project files will be available on Patreon. If you like to support the channel, that is the best way to do so. So, I hope you learned something cool, something new. I mean, that's what we like to do. We not only create stuff, we let you create with us. Hit that like button, comment your thoughts below, and don't forget to subscribe to HellFX Learn so you won't miss out in the next video drop. So, until next time.